some understanding. Rules are just kind of like a property in a way. All right, we've figured this out. We did the formal definition of the derivative, and it came out to this. So now we don't have to keep doing the formal derivative. We can use these rules or these shortcuts. Okay, we have specific rules for derivatives, and then we have some general rules. General rules say if we have the derivative of f of x plus g of x. In other words, two things. Maybe one is like x cubed plus x squared. Those are two separate things added together, okay? So we got this general rule now that says, well, that's just the derivative of f of x plus the derivative of g of x, okay? You might say it kind of looks like a distribution, and in a way it kind of actually is a little bit, but this is our general rule, our sum and difference rule, okay? So take the derivatives of different ones. We also said that if there's a constant, you can pull the constant out. So those are general rules. They help us work with a wider variety of functions, kind of like we saw in your little warm-up chat, all right? A couple of us got kind of creative and had several terms. Okay, well, now the question is, what if we're not adding these functions, but what if we're multiplying two things together? Well, how does that work? All right, well, we're going to kind of derive this. This is not, we're going to look at a couple proofs that you won't necessarily need to reproduce, but let's look at them together, okay? So first, with the product rule, we've got to look at things like this. What if we have x squared times sine of x? How do we deal with that, right? So let's investigate here, and let me make a little, let's try this. Okay, let me see if I can get a little, there we go. All right, cool. We'll ignore that. So first thing we're going to do is this, okay? Put your thinking hats on. Here we go. So we've got some derivatives, u prime, v prime, all right? And we, u prime is, let's just write it this way, it's the change in delta u, meaning that little change in the y value minus the original y value over the change in x, okay? So that's just a little kind of shorthand notation for our limit definition. Okay, same thing for v. We've got another function v, and we'll say that it's the change in v, which is the change in y values, over the change in x. Okay. So we're going to kind of just define that there. Now, okay, the question is, what if we have the derivative of u times v? How do we deal with that? Well, we've got this. We have u times v prime, or the derivative of u times v. All right? And so that's going to be the change in u times v minus uv all over delta x. All right? That's our limit definition. Now we've got to work with this. All right? I wish it said something like delta u minus u over delta x, because then I know that. That's the derivative of u. Or this is a derivative of v. So I'm going to try to manipulate this a little bit here. All right. And let's see if we can change the way it looks. So we're going to take this function up here. Okay. Delta y times delta v, delta u times delta v minus uv. There's our formal definition. And we're going to add these couple little terms just for kicks. U times delta v, u times delta v. All right, just for kicks. All right, and we can factor. So if we factor out a delta v, it looks like this. If we factor out a u here, it looks like this. And there's our delta V minus, okay? And with a little bit of careful algebra, we have this times delta V, this times delta U, and at the limit, this is just the derivative of U, this is the derivative of V, okay? All right, and as that delta x goes to 0, this just becomes V. So moral of the story is this. We have the derivative of the first function times V plus the first function times the derivative of V, the second, okay? So again, nothing to reproduce there, but that's kind of the thinking very quickly of where this comes from, okay? So here's the key. And this is something we'll use a lot and have down pretty soon. The derivative of u times v is the derivative of u times v plus the derivative of v times u. All right, and you'll see this in a couple different forms. In fact, if you look in the book, you'll see this. You'll see u prime v plus v prime u. Okay, hopefully you see that that's the same thing. I'm going to encourage you to remember it in this order because it will apply to our next one. Okay, it'll apply to dividing. So, derivative of u times v plus u times the derivative of v. Okay. So, derivative of the first times the second plus the first times the derivative of the second. That's all that's going on. What does that mean? Well, let's try it. Here's two things multiplied. There's our u times v. Okay. And we just came up with this formula that says f prime of x is u prime v plus u v prime. Derivative of the first times the second plus the first times the derivative of the second. Okay. So let's take the derivative of the first. Derivative of x cubed, 3x squared, times v, 5x to the fifth minus x squared. Plus, don't stop there, the first, x cubed, times the derivative of the second. Now, hopefully with some practice, we can find our derivative pretty easy. Drop the 5 down, multiply it times the 5, we get 25, x to the fourth. Minus, drop the 2 down, 2x, and subtract 1, 2x to the first. Okay. There it is. On the AP test, that would be fine, unless it's a multiple choice question, and that's not one of the actual answers. Then we might have to simplify it. Let's see. This is 15x to the 7th. Remember, we add the exponents, right? 3x to the 4th. And we got 25x to the 7th minus 2x to the 4th. What does that come out to be? 15 plus 25, 40. X to the 7th. And minus 3 minus 2. Minus 5, x to the 4th. There it is. Equivalent to this. Okay? Now, by the way, we could have distributed this and said this is 5x to the 8th minus x to the 5th, right? If you distribute this out. And if we take the derivative of that, we get this. So in this case, we could have distributed and not used the product rule, but it's good practice. Any questions there? Derivative of the first times the second plus the first times the derivative of the second. Okay? All right. Let's do one more. I'm going to skip C for sake of time, but let's try one more, and then look at the quotient rule real quickly, and we'll call it good. So this is u times v we have derivative of u times v plus u times the derivative of v. Derivative of the first, 15x squared, times the second, cosine of x, plus the first, 5x cubed, times the derivative of the second. What's the derivative of cosine? Just sine?
Negative sine.
Yeah. Negative. And that's about it. 15 squared, put that negative sign around. Cosine x minus 5x cubed sine x. Derivative of the first times the second plus the first times the derivative of the second. Okay? All right. This one we did, by the way, we'll look at it tomorrow, but you'd have to deal with the product rule there and then do the 2 sine x separately. Quotient rule, all right, let's look a quick look here, all right. If we approach it kind of the same way, you can think through this. We're not going to drag through it right now, all right. We can find the limits. This is really saying all of this over delta x. Okay. So if we're looking for the quotient u divided by v prime, then we're going to end what we end up with here is we're going to end up with, in the end, again, not going to drag through it, but something that looks very similar. U prime v minus uv prime, and then we've got all over v squared. Okay, now that came from, looking at the beginning, u over v there. Okay, well, all right. So the bottom doesn't totally go away. We start with a fraction, we end up with a fraction still. That may or may not simplify. Okay, but notice this is derivative of the first times the second, first times the derivative of the second, minus. All right, so addition or multiplying goes to add, dividing goes to subtraction. Let's try 1 and we'll call it good. Okay, so we've got a quotient here, 2 things being divided. Okay, so we're going to use this rule here. So we're going to have a fraction. So we have derivative of, instead of a first and second, we have derivative of the top. Okay, so think of the top as the first, bottom as the second. Okay, so derivative of the top is going to be, drop the 2, it becomes 8x. Derivative of 1 is 0, right? Constants go away. So, oh, that's nice. So it's just 8x. That's the derivative of the top times the bottom minus the top, 4x squared minus 1, times the derivative of the bottom. And what's the derivative of x plus 3? Well, that 1 exponent on the x goes down, and the derivative of x is just 1. Okay, so times 1, which obviously can go away. And on the bottom we have x plus 3 squared. Okay. All right, we'll do a little cleanup here, and if nothing's going to happen, then we'll leave it. In other words, if we can't cancel out an x plus 3, we'll leave it alone. So we have minus 4x squared plus 1 all over x plus 3 squared. And it looks like that's going to end up with what? 4x squared plus 24x plus 1 all over x plus 3 squared. We don't need to multiply out the x plus 3 squared. Our goal in doing this simplifying would be to check and see if x plus 3 goes into this. And I don't think it's going to. Okay, it's not. Okay, you can try to factor that. X plus 3 is not a factor. That is our solution right there.